Can't imagine why.
Jack was gonna go and take some clips.
All right, number one.
Can I sit right here?
You should have.
I'm the special class, guys.
Number one. This is Le Chatelier's principle, right? Here's a stress.
Yep.
Here's an equilibrium.
Yep.
What's it gonna do?
Yeah.
Pressure. Pressure is related to the moles of gas. We need to compare how many moles of gas we have on the reactant side and how many moles of gas we have on the product side. I have 9 moles over here, 10 moles over there. Okay, there's a difference. If they were the same, it wouldn't matter. Any difference in pressure, if the moles of gas on both sides are equivalent, does a whole lot of nothing. But they are different. So let's think about what an increase in pressure is. An increase in pressure means I'm decreasing volume. Okay? And if I am limiting the space or squeezing down the volume of this chamber, the stress is I would want less gas in there, right, to kind of relieve this change. And as a result, we would expect our equilibrium to shift towards less gas. Okay? The hard part is when you think about it in terms of pressure, I don't know if you can really visualize it, but when you switch that pressure change into a volume change, I think it clicks a little better, right? Increased pressure is decreased volume. Decreased volume means less space. So if there's less space, I probably want less gas. On the opposite side, if I decrease pressure, that's an increase in volume. I've got extra space. Now I can fill it up with more gas, so I want to shift towards more moles. Okay, maybe that makes more sense. But anyway, so here's my shift. All these other things are going to change based off of where we're headed. So that's going to go up. This will go up, down, 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 and K doesn't change unless we have a change in temp. Change in temp, decrease temp. Energy is going down. That's the first arrow I'm going to put in. As a result of that decrease, which way am I going to shift? I have to shift towards it to replace what I just removed. Now all of the other arrows are going to fill in based off of that shift. This will go down, down, up, up, and then K actually does change because we had a change in temp. Which way are we going? Towards the products. K is products over reactants. We're making more products, our numerator is getting larger, our value of K is getting larger. Add CO2. I'm going to put that arrow in first. That's my stress. As a result of adding that product, I'm going to shift away from it to remove that excess. And as a result, my other reactants will increase. The other product will decrease. Energy decreases. And K goes unchanged. Add water. The product. This will be the first arrow I add. As a result, we will shift left. The reactants will increase. The other product will decrease. And K will go unchanged. I'm flying through this. I hope you're following my logic as I talk. Oh. Remove CO2. First arrow I put in is that. As a result of that removal, I need to shift to replace what I took. We shift to the right. Reactants will go down. The other products will go up. And K will go unchanged. Add oxygen. That's a reactant. I'll put that arrow in first. I'm adding something on the left. I would shift away to remove that excess. As a result, the other reactant goes down. All the products go up. And K goes unchanged. Yes, sir.
For the first one,
Yep.
you have more, you have fewer products, more reactants. So, they on the same.
No one asked us when we did it the first time. The hard part is when we talk about changes in pressure, we have the other variables at play, right? The question is literally, if pressure changes, what other variable is going to have to change, right? Because we have volume, we have temp, we have moles. Volume, temp, moles, and pressure are all related to one another. And depending upon the circumstances, you can change all 4 of those two of those, you know what I mean? Like it's
Yeah.
tough. Now, what I will say is there's many a good article on why a pressure change doesn't affect the value of K. But having said that, if a pressure change is related to a temperature change, then K would change. We're assuming temp is constant with that statement, and I really don't want to get into it. So I apologize for my sidestepping of your question, because it's a very good question. It's a question that literally Schreiber and I talked about and argued about for like 45 minutes one year. Not argued, but we had a good conversation.
Violent.
Yeah, I mean, I broke a stool over his back.
Nice.
Got ridiculous. No, but literally Schreiber and I have talked about that for like an hour, because he was like, I don't get that. So then I explained the whole thing to him, and he's like, I still don't get it. And I'm like, yeah, it's kind of dumb. It's weird. So if you Google it, you'll get all sorts of fun articles with people confusing the crap out of you in like a couple sentences. Yes?
So can you just explain the increasing pressure one?
Yeah, I can. Yeah, so in the context of what we need it to be, right? So when you increase pressure, I like to visualize a volume change, because that just feels more tangible. So an increase in pressure means that I am decreasing volume. Say my chamber was this big, now I've smushed it and it's smaller. So there's less volume, less space in that chamber. And as a result, to kind of relieve that, I would want to have less gas in there. So over here, I have 9 moles of gas. Over here, I have 10 moles of gas. So that smaller space means my reaction wants to have less gas molecules in that area.
Okay.
So an increase in pressure, we would shift towards less gas. A decrease in pressure, we would shift towards more gas. And the opposite reason would be true, right? Volume gets bigger. Now there's extra space, so we want to fill that with extra gas, so to speak. A little funky. All right, I'm going to keep going here. Keep trying, keep going.
Wait.
Oh, I'm sorry. Yes.
So, on one of the, like, when we did this before, we added 8.
Like this? I added, what did I add? Yeah, go, find it if you can. There's a lot here, keep going. We kind of we're off to a little bit of a slow start, but please keep trying this stuff. And again, the answer key is on its learning.
What you get? Because I did it twice and I got 2 different figures.
Well, by the way, this is not.
I am on 2A, which you could pretend. That's what I got. Oh, sugar. It's 4.0.
Water is 4.1. Yeah.
Not really sure everybody is not.
So 4.1. So it's normally it's more. Yeah, but that's calories per gram of celsius. Usually. Okay. Joules is kind of one, I feel like. Kind of, yeah. Okay. So anyway, so this is your hot water setup. Your cold water is the same darn thing. Mass is different, 30. So the heat factor is the same. And then you have TF minus 280. Yes. But we've got to flip the sign. Because this Q should be negative, this Q should be positive.
In order for these two things to be equal, I have to flip the sign of this whole side.
Isn't it just?
So I'm gonna have negative
Which way
this
it will shift?
Well, yeah.
equal to
You have to figure that
positive.
out.
You distribute, yeah, so like,
Six and
well, it'll be what, yeah, so I mean, yes, this whole thing.
I got
has-
6.
So you have negative
I got
50.
6.
Well, we gotta be careful. Yeah, be careful with the sign.
How do you know?
The negative sign is distributed through.
You feel like,
Isn't it, doesn't it go?
okay, it's
I
not.
found it.
Oh, yeah.
Okay. Yeah.
We added and then.
Oh, yeah, so that was what the side reaction. That's actually more than yesterday. I don't know if it applies, let's see.
So B explain.
B is right.
Doesn't really apply. Because
We did two different numbers.
these are neutral compounds.
Yeah, you just use the numbers.
The reason why I added that one is because we had, acid, right? So that would break that to acid. In this instance, well, A, these are all gases, so we also can't get hydroxide into a gaseous. But
What?
Yeah.
Okay.
Number 3, what we're doing with the cross field.
Yeah, we wanna, yeah.
Thank you.
Okay,
Correct, I want those two steps to add up.
got it. And then what do we have to do with these stuff? Wait,
So-
oh, and then we use, oh, and then we add those two together or whatever?
Yeah, careful.
Wait, how do you flip, wait, don't you like square and stuff, or like,
With,
And stuff.
with equilibrium constants. If you flip the reaction, you end up needing to hit the reciprocal of the K value, meaning like 1 divided by.
so you,
And if you double the reaction, you need to square. But yeah, so when I combine it, right, K values get multiplied together. So let's say neither of those got flipped, neither of those got changed in any way, shape, or form. It would be K1 times K2.
what's it?
But second one, we flip it or something. I'll get there eventually, obviously, too.
So,
Yeah, for two, sorry, get
4.0 times 10 to the 6.
Alright. What? Is it alright?
You're the same color.
Did you?
Oh,
They got this easy. 10 to the 6.
Yeah, so you can like look farther into the.
It shifts to the,
You can look farther into the decimal to see which one's bigger.
no, you should.
Oh, it's nice.
yeah. Create a value for the equilibrium constant. Wait, oh my gosh. I know, I might know. So you cross out NO2, NO. Wait. I don't know. I feel like you can, because I feel like we did.
Is O2 supervisor?
Yep.
Did we do this in this lesson earlier?
Did we do what?
The crossing out?
Yeah, we
Hess's
did.
law, yeah.
But can, you have to, which one is like, or can you just, because there's 3 O's on both sides, one of them O and O2, and the other one's O3. Can you add the O and O2 together?
Nope.
You can't do that.
Yeah. Dude, that's why the reaction is what it is. Because it's N,
that makes that,
it's O and O2.
but that means this is progress. I think
Hey, what'd you guys get for a value of K here?
4.0 times 6.
Can I get that signed?
Times 10 to the 6.
Thank you. 4.0 times 10 to the 6?
Yeah.
Sweet. Any questions there? That's about as easy as life gets, right?
No questions.
Okay.
He
My
just
bad.
messed it up.
Yeah, we're good.
I just needed to read my own question. Okay, so same setup, different numbers.
Confusing.
I don't know. You do.
So what?
Arrows go both ways.
That doesn't.
Wait,
This, the old three supposed to be on.
That's what I'm saying.
so you have to know which, you have to pick one of the keys.
No, you multiply them for you.
What?
It's a negative.
No.
Just like the case.
Right.
Since everyone's so lively on the next one, what's Q?
4.0 times 10 to the negative 10 to the 6.
It's like you bigger.
It's 10 to the 7. Doesn't matter.
I thought it was 10 to 7.
Doesn't matter.
Did I count wrong? I must-
Did you square that or something?
I don't know, I don't know, I just counted wrong probably. Like,
Which way are we shifting?
No shame.
What's that? We're there. No need to shift. Okay?
You literally just.
We don't give a shift. Thanks.
What? I didn't hear it. What was your-
My favorite type of laughter is pity laughter. Thanks, guys.
What did he say? What did you say?
I don't give a shit.
That's so funny.
Thank you. I can tell from your authentic laughing. Yes, Dylan. So, okay, you're right. It's like just slightly off, right? Isn't it?
It don't matter.
Then you've calculated wrong.
I need to count again, I thought it was 10 to the 7.
No, dude.
I'm pretty sure it was off by like, shouldn't even be that much, I don't think. Really?
No.
Do you have the right numbers in the right spots?
No.
No, I don't wanna hear your. I'm taking up.
Because I mean, these aren't in order, right? So be careful where you're putting them, but
4.04142119. Times 10 4.0449902234.
Yeah, that didn't, I didn't remember.
What? Brainer.
I was like,
Can we just move to 3?
well, I'm just.
This is right.
This should be right.
It is right.
Okay.
You're off by a little bit.
No, you just probably typed it in.
It doesn't.
And what is it outside?
Oh, I suppose. Okay, well, here's what I'll say. If it's not perfect, right, when we round for sig figs, it should be the same. And even if I don't round for sig figs and it's off by like, you know, a smidge, it's,
It's not big of a number though.
at the end of the day, hold on, let me say it this way. At the end of the day, if on a test, if I gave you a problem like this and I was trying to make it equal, but you made the argument that it was slightly off, so you chose like the correct direction of where it was slightly off, I would give you credit. They wouldn't phrase it, they wouldn't give you a question that was open, they wouldn't give you a question that was gray. It would never be given to you it would be very black or white.
They did have the ACT one.
Yeah, the ACT.
I was gonna say, geez.
Yeah.
The whole ACT was just.
The math.
All right, since you're having fun here, let's go through this.
Okay. I have no idea. Dude, you can just flip it and then you.
Yeah.
That's something.
And then you have to.
Now, whenever you try to do these Hess's law problems, right, and you're trying to figure out, you know, what you're flipping, what you're doubling, what you're whatever, you want to isolate or find where there's like only one possible reaction that's going to give you what you need, right? At the end of the day, what I want is I want O3 on the product side. That's the only place it exists. The only possible way I can get O3 in my overall reaction on the product side is to take this bottom one and flip it. So let's do that. Okay? Now, I only have O show up in one spot as well. There it is. The only possible way I can get it on the reactant side is to flip the first. I have O3 on the right side. I have O2 on the correct side. I have O on the correct side. Everything else should just work itself out. Now, you need to probably verify that it does, but if you get everything in the right spot up here, everything down here that we don't need should cancel out. And we can just check, I guess. So NO2 would now have showed up on the product side. This NO2 would have now shown up on the reactant side. Those will cancel. This NO would now show up on the reactant side. This one would show up on the product side. Those will cancel. And we're left with what we need. Right?
Yes.
Now, with K values, we multiply them together. If I hadn't done anything down here and it was just this one and this one, normal, no flipping, no doubling, whatever, it would be that times this. Okay? But when you flip a reversible reaction, we take the reciprocal of the K value. So this turns into 1 over that and 1 over this multiplied together. So I get my new K, the K of this guy, equals 1 divided by 6.8 times 10 to the negative 49. Multiplied by 1 divided by what'd you get? Huh?
Can you just say the 6.8 times before can you just say it's negative? No?
Uh-uh.
I got 2.5 times 10. Did you do the Hess's law lab?
10.5, sorry, 2.5.
2.5 times 10 and 8.
Okay. Positive 81.
Yeah.
Okay. So let me go back to that, Emerson, because that's a good question. So we've used Hess's law twice in this class. The first time we used it, we were combining reactions to solve for delta H, which is enthalpy. When we solved for enthalpy, we added up all of the delta H's. Anything we flipped, we turned negative. And anything we doubled, we just doubled the value of delta H. For K, it's different. We multiply these together instead of adding them. When you flip it, we take 1 over, or the reciprocal of it. And when we double it, we would actually square the value. If I tripled it, I would cube the value. So this process is the same, right? Taking multiple steps to turn into one step, that's the same conceptually. But how we manipulate the value that we're interested in is different. Make sense? Keep going. I can help you now, Logan.
Oh, I didn't know this. I feel like you don't do
Well, that's, again, this whole time, I would do this probably like, like, ignore the negatives right now. Combine the like term. So this times this times T, I'm sorry. This times this times T. And then just put the sign of both of those.
How can you do
Yeah.
but you can combine them, even though.
Well, for right now, ignore these. For right now, let's just deal with it. Because the math will work itself out, and we'll deal with the unit in the end.
Oh, yeah, okay, no, it's 2.0.
Right.
So as soon as you said that you do that, this is going to be
The initial.
Mr. Ross,
Mhm.
who do you have winning your March Madness?
I haven't filled out yet.
Really?
I'll do that.
Yeah, it's gonna start tomorrow.
Like,
I'll probably have to do that. It's right.
Oh, yeah.
Boring.
Come on. That's ridiculous. They haven't lost them all. They,
I don't even know what to do for that.
yo, what's her name? Old lady who's like.
What?
I don't know.
Wanna get you these
Elder.
I don't like.
I couldn't hear anything. You just set up your table like this.
Yeah.
I guess I would recommend you.
Well,
Okay, I'm finished. You have your initials in there, right?
Yeah.
Which side has more?
What? You go to the right.
Right.
Oh, that makes sense.
At least I'm pretty sure.
why don't we just set
I could figure out.
it?
So I just need to.
Yeah.
You just said it, you have to go.
Yeah.
So like it's
Oh, God. So screwed.
So it's dividing by the first two, and then slowly multiply by times.
What?
Oh, yeah. Like, wait.
I need help on this one.
On this one?
Yes.
Yeah.
All right.
It shouldn't be hard, but it
Oh,
is.
like that, like this. Freaking I go along.
Wait,
So I got the table, I just totally picked on what I need to do.
Huh?
that's the,
Because it says the initial is 5, so you can't have any, because that's equilibrium. The 2 is equilibrium.
Oh, I'm sorry.
I'm so smart. I'm just kidding. I'm actually not.
Suppose I shouldn't fill these in yet, but we'll leave it like it is. So,
no. Oh my God.
It's okay. That's just, we know what X is.
do we?
Yeah.
Yeah, I think so. Because 2x equals 2, right?
Yeah.
Oh my gosh.
So, what's KP? Well, KP would be 5 minus 1 is 4 for that, right? Let me just set up K, I suppose. We should totally do that. Kp equals the partial pressure of NH3 squared divided by the partial pressure of N2 multiplied by the partial pressure of H2 cubed. So this is going to equal my product, which is 2.0 squared, divided by my reactant, which is 5 minus 1, so that's 4, multiplied by 5 minus 3, cubed, so that's 2 cubed. What do you get for a value K? Should be 1/8, isn't it?
1 second, I'm almost there, don't worry. Yeah, don't worry. Thank God.
So what is that, 125?
Yeah.
Thank you. I'm sorry?
You gotta eat it, but how easy it was.
That was really complicated.
It was?
No.
It's just, I mean, yeah,
Yeah, we were.
you know, and I know we've been doing ice tables for a little while here, but this is an example of where that ice table really helps. Because we put in what we know. It told me this initially, and it told me that at equilibrium. And then you kind of use it to work around and get the rest on, right? Yeah.
Just forget something. How do you determine minus or plus? Like which one is minus or plus?
It's where it's shifting. So in this instance, this is where I was initially. I can't possibly go that way, can I?
Oh, you're right.
So I have to go that way. That has to get up. That has to go up. These have to go down. So yeah, it's a shifting question is what it is. And now the hard part is if I've got something for all of them, right? Then I have to solve for Q. But if I've got a 0 on either side, I'm going towards the
Is
0.
one of those gonna be at the test?
It's one of what?
Yeah.
Yeah.
Thank you. Let's go. How
Any
many
questions
questions are there?
Couple?
I think I might pass.
There's 27.
27 an hour.
That sounds about right.
Okay, so in anticipation for the test, what's your definition of Q again? I know, but like. Well, like if he says like, what is
I mean,
Q
he's not
stand
wrong.
for, or like what is K?
I'm not giving you definitions tomorrow, but Q is called the reaction quotient, and it is solved mathematically as product of a reactants. It represents the time not of K is solved for the exact mathematically exact same product of a reactant, and it's active fluid.
Not asking for that.
Yeah.
No.
That'll be the first.
I'll take some definition.
Yeah, I haven't done a definition thing with you guys at all, and neither does AP. Really. AP doesn't really pound definitions at all.
Easy cash flow right there. Speaking of cash flow, I want to download my network app. My coin?
Oh, and that's,
What?
yeah, I have that on.
No.
Okay.
Like,
Oh,
invested in the future.
Gosh, I don't do that.
It's free.
Well, I do, but
You don't have any money, but it could be worth a
I don't
lot.
think that's very good.
I don't have to read it.
So I don't know what I did.
You want to do it? Okay, I'll send you the, I'll send it to you right now, for free.
Are they both supposed to be negative?
I think that's
Use code cousin Luca.
that's supposed to be negative, this is supposed to be positive.
Oh, I thought the. the negative something negative.
But then this would be negative too.
So I messed up on the sign of the later here.
Kind of.
But I didn't even put it in the sign of the.
No, this is the piece, don't get me wrong. Make that negative, make that positive. Make that mix sort of thing.
Okay.
I say, always, usually.
Thanks. Oh, that was.
Verizon, like,
Yeah.
he's getting you into pie today.
Who is?
Will?
Yeah, good luck.
Wait, what does that mean? Oh.
You want-
I-
I'll send it-
no,
I'll send it to
no,
you.
no,
You
no.
want?
You guys act like I haven't already established my own pyramid. I don't get that.
Whoa! You're in?
No, I'm kidding. Okay,
Dang, I was gonna say, you just played us.
I'm glad that got you pumped.
I sent it to you. Code Puzzle Luca. Helps me out. You can just download that. I'm like, yeah, this is good.
What?
Don't do it.
Teaching? I don't know.
Luca, what?
It's not very lucrative.
My portfolio.
I got none.
What, 14?
Got none.
I don't believe it.
That I'm not a hustler.
No, hustler or grinder. So speaking of hustling,
Yeah.
do you wanna invest in your future? It's free,
I'm sure it is.
but it could be, it's like the new Bitcoin.
It sure isn't.
Because, well, dude, it's the only one that you can mine on your phone, therefore, big gains. Huge, not even big, huge. I don't think he's buying it.
Really?
If you do ever think about it, code Cousin Luca.
Why?
Because every other freaking username was taken, so I just had
Because it's so popular.
That doesn't say right with me.
Cousin Luca.
No.
Is that like how you address yourself to your cousin?
No,
It's me, cousin Luca.
we never
In your head,
see
you're probably like.
Sorry, I caught like a hint of Mario in there. It's a me.
That's not even a. You're like, oh.
Dude, you
That's
with like a super like floaty little environment, like commercial ad that looks like it's gonna.
He's actually gonna run with this, that's the bad thing.
Who? Dude, they have like 13 million downloads. They're blowing up.
Then you don't need anyone else.
Well, dude, if you use code Cousin Luca, it brings my
Oh,
pie
really?
per hour up.
But wait, there's more.
Yeah, that means I'll get to like 60 pie coins, which is probably like 16 grand.
What is it?
Call now.
It's all fake.
It's not.
Completely.
I already sent you the link on Snapchat, just download it quick. Just download
I think I'm okay.
Just.
Wait, confirm this for me and I'll consider it. Isn't Will at like 70 points?
Yeah.
I gotta pitch it to my mom.
I might just take my parents' phone to do it and then delete it.
And we never heard from him again.
Oh, never mind.
We'll mark this date, because everyone that said no. And I'm just swimming in my freaking liquidation
I don't think I want any part of that.
funds.
You don't want to be a part of the liquidation? Like,
He goes,
cousin
I'm part of
Luca?
my liquidation. And then stop. That's pretty much.
Well, you didn't have to take it that way. You're the only one. Liquidation with cash flow.
Yeah,
Well,
he
you
also
mean-
thinks that it's normal to call him cousin Luca.
Dude, have you never seen that guy on TikTok? What up, gang? Never?
No.
That sounds like every guy.
I have to rack my brain for a
It's
minute
cool.
there.
It's cousin Barad.
Uh-huh.
Maybe that's what it's called.
Oh, no. I say go for Senor.
Senor Barad.
That is a good one.
Would I get extra credit if I started calling you cousin Barad?
I'll give you two guesses, but I think you only need one. Sorry, I'm feeling sassy.
Yeah. I'll tell Jack to tone it down a little bit. Barad, cousin Barad.
Is Jack like
No, but she's friends with Barad.
Now I got two.
Wait, does he
Bill and I have
do the claps?
What?
Oh, I'm sorry, I can't round, my bad.
Only class.
I was
What'd you
gonna
say?
say, but then I-
Sorry.
I thought this was his only.
No, I'm not, yeah, I don't know what, I don't know, I have no clue what I'm looking at.
Oh, Jack. Why would that be there's so many Jacks.
But there's only one that's relevant. I'm kidding, for anyone else named Jack. You know,
Nobody else in the world named Jack, I agree.
I just started beating every Jack.
Wait,
Great.
can you? I think, I don't, I have.
Oh, shoot. Sure, I can. Hey, if you gotta leave, you gotta leave. Grab a wipe, sanitize, por favor. Test this tomorrow. All these answer keys are posted for the regular review, in-class review, and pre-test check. Test this tomorrow.
HOCL, I got 0.066.
Did you round?
No, it just gave me that. That's all it gave.
No, did you round the one before the?
Oh, yeah, I did not use this.
Oh, okay.
I used the unrounded version of the 0.217.
Okay. I think I read up a grand reveal.